Hello, this video will show you different features in Drishti import. This is version 2.2. We have added handling of 16-bit data in version 2.2 now. So let's see how to load and save 16-bit data and how to manipulate the histogram for 16-bit datasets, or the same thing, the same principle will work for 8-bit as well as 32-bit datasets. So let's load a TIFF directory here. So this is a TIFF directory that I will be loading. So I am dragging and dropping this TIFF image directory. So this is grayscale TIFF. These are 16-bit images here. Now here you don't see any histogram, but there is a histogram. Press H and then you will see the histogram. So press H. So initially what you would be seeing is something like that here. Actually the histogram is somewhere in the middle. So if we use the middle mouse button, wheel it down, you will see that your entire data range is this big, and initially what I would have been showing is just tiny, this part. So press H, that is home, and you will see your maximum and minimum range. So this is your maximum and minimum range. That is the entire value range for 16 bits, so which is from 0 to 65535 for unsigned, and then minus 32768 to 32767 for the signed. In case if it were 8-bit data, then it would be 0 to 255 for unsigned character, and then minus 128 to 127 for the signed character. For int it would be 0 to max int, whatever that big number is. Similarly for float. So you might start with an empty screen because it might be showing just this portion of the histogram. So when you press H, it will always take you it will always place the minimum and maximum between these between the window. So press H to get minimum and maximum within the available window, and then you can use, if you have a wheel, mouse wheel, then you can use middle mouse wheel to change the size, the horizontal size of the histogram, or you can use left key and right key. So right now I am using left key and right key on the keyboard. So this is using left key and right key on the keyboard. Now if you are way off, then you can easily press H to bring back the histogram in to fit within the window. So pressing H will set the histogram to fit within the window. Using left key or right key, you can change the horizontal size or the extent of your histogram here, or you can use wheel, mouse wheel, to change that size. Similarly, you can use up arrow and down arrow to change the histogram height. So right now I'm using up arrow and down arrow for changing the height of the histogram. Here, let me press H again, and you have the histogram fitting within the available window. Now you can change the minimum and maximum by moving these markers here, and you can see the change in this image here. So whatever color map we have on top here, that will be mapped onto the image here. So if we change the color map, so hover over this color map here. So I'm hovering over the color map and then press space bar. So this is same thing in Drishti, the renderer, where you hover over your color map and then pressing space bar will bring up different options for the color gradient. So similarly, by pressing space bar, you get different options for the color gradient. So, and then you can of course change the color gradient to whatever colors that you feel like, or remove, and so on. So or you can flip using F and so on. So you can play with the color gradient as well as the markers. Now if you know the exact values for your minimum and maximum, now here I am just moving the markers and changing these minimum and maximum extents for my color mapping. You can feed in the exact values for your minimum and maximum extents. So hover over the histogram and then press space bar. So when I press space bar, I can enter minimum and maximum values. So for example, say 31,000, say 500, that's my minimum, and in this case it's about say 35 or 34, 3500, 35,000. So these will be my minimum and maximum extents. So this is how, so this is 31,500, this is 35,000. You can also add markers. So for example, I can add a marker here, or I can just give a value. So to add a marker, I have to give marker and then a specific value. So in this case the value would be say around say 32,500. So here I have added a marker, or using right mouse button you can remove the marker, and by right mouse button you can add a marker. So I have added a marker with right mouse button, added another marker with right mouse button, and then what I can do is I can change these markers. This is a way of increasing the contrast in your data, especially if you want to go from 16-bit or 32-bit to say 8-bit or 16-bit. Now these are the mappings for changing from your 16-bit data to 8-bit data. Now if I want to keep it as 16-bit, then you can change your output type to 16-bit and your markers will change here. Now because you are working on 16-bit, you need not change the contrast, but it's entirely up to you whether you want to change the contrast. Now here, as you can see, because we have added the minimum and we have changed the minimum and maximum from 0 and 65535, these are mapped to 31,500 and 34,500. If we save that as say 16-bit, then what we will see are big gaps between different voxels, because we are mapping say 31,000 and 35,000 to 0 and 65535 respectively, and then everything in between will be linearly mapped. So if you want to work on bare the original 16-bit data set, then you should put these markers back to 65535 and 0. So this is your original data here. So I'm using left mouse button to get the original to fit the map into the original histogram. So this is your original data, 16-bit data, and the output type is 16-bit. If I make the output bit 8-bit, then these values will get mapped from 0 to 255, and in that case it's better to remap your data so that you get the required contrast when you're doing the final rendering. Okay, so most of you would have worked with 8-bit renderer, so let's try this one with 16-bit rendering. So in order to do that, we will have to save the data or output as 16-bit. So here it is 8-bit, the value is 255, so let's change that to 16-bit. That becomes 65535, and now let's save that. So let's save as say test 16-bit. All the other things are same as handling of 8-bit dataset. Okay, we are done. So this is how you work with you save your 16-bit data output from the importer. You can also import say 8-bit data and then save it as 16-bit data. It's no problem with that. The importer will allow you to do that. You can save say integer data or float data into 8-bit as well as 16-bit data set, and these your data, the pvl.nc file, if you are saving 8-bit output, then it will be saved as unsigned char, and if you are saving it as 16-bit, then your data will be saved or remapped as unsigned short 16-bit. So that's how you can save 16-bit output using the version 2.2 of Drishti importer. In another video we will see how to load and work with 16-bit dataset in the renderer.